Good morning, sir. Good morning, Gouss sir. Mohammed sir. Very good morning to you.
Yeah, am I audible to you, madam?
Yeah, yes, sir. You are audible.
Okay.
Sir, yeah. Just can you check side whether you can share the PPTs?
Yeah, that's what I'm doing, madam.
Sure, sir. Sir, we can see the screen.
Are you able to view PPT, madam?
Have you opened the PPT, sir?
Yeah, I have opened that.
I couldn't see it.
Okay. Just a minute, madam. I'm once again doing that. Now, is it visible, madam?
Your desktop is visible now.
Okay. Not the PPT.
Yeah, not the PPT. Just click on that, sir. Let's see.
Now, madam?
No, sir. It's not visible.
Okay. Now?
No, sir. Sir, click on that PPT, sir. I think it may open. Double
This
click on
one?
that. Yeah, double click on that.
Okay, madam.
Sir, not able to see.
Okay. One more time, I will try to.
Yeah, sure, sir.
Okay.
Yeah.
Now?
No, sir, it's not coming.
Okay.
Other participants, are you able to see the PPTs? And this time I want to see whether my side network connectivity is not there or not. Just want to check. Yes, sir,
No.
it's not visible like that.
Yeah, okay.
Sir, if you double click on that, is it not opening if you double click on that?
No, madam, that's not it. Yes.
Sir, how you are sharing the screen? Share the desktop, sir. You open the PPT, then in the Teams share option, in the share, you share the desktop, not the PPT app. Desktop you have to share.
Okay, madam. Ram, sir.
Sir, it is visible now.
Okay, madam. Okay.
Yes, fine, sir. I'll just welcome you for this session, sir. Just 2 minutes give me time, then you can start the session, sir. A very good morning to one and all present here. On behalf of Gopalan College of Engineering and Management, a warm welcome to you all for 5th day AICT sponsored online STTP on cyber criminology and network security. And also I welcome our today's resource person, Dr. Gouss, Baig Mohammed, for today's session. And the session is about cryptography. Before we start the session, I'll give you a brief introduction about our eminent resource person, Dr. Gouss Baig Mohammed. Dr. Mohammed completed his PhD from Acharya Nagarjuna University and MTech CSE from Jawaharlal Nehru Technology University, Hyderabad, and BTech from Kakatiya University, Warangal. He has overall 15 plus years of experience in teaching and is working as assistant professor at Vardhaman College of Engineering. Worked as assistant professor in Mufakham Jha College of Engineering and Technology, Hyderabad. Worked as assistant professor in Southern College of Engineering, Hyderabad, and worked as assistant professor in Wazir Sultan College of Engineering. His area of interest his research interests are network security, cloud computing, computer networks, and Internet of Things. He has attended various of workshops and he has published various papers in international journals and has 5 Scopus publications. Sir was a resource person for blockchain technology FTP conducted by KHMIT Guntur, and he was a coordinator AI conference conducted by Vardhaman College of Engineering, and he got selected to play in the South Zone table tennis competitions consecutively for 4 years and has captained Kakatiya University table tennis team for the last 2 years. I cordially welcome you for this session, sir.
Yeah. Yeah, am I audible?
Yes, sir, you are audible.
You people are able to see my PPT over there? Like
No, sir.
No, once again. Okay, once again I will browse and upload, not an issue.
Yeah.
Okay. Yeah, now?
Yes, yes, sir, it is visible.
Yeah.
Taking
Shall I
time
start
to
this?
load. Still it is loading.
Okay.
Yeah, yes, sir. It's visible now. You can take over the session now, sir.
Okay. Good morning, all. First of all, I would like to thank Gopalan College of Engineering for giving me this session, and especially the Somashekar sir. Let me introduce myself. Myself, Dr. Gouss Baig Mohammed, presently working as associate professor. Now I have been promoted to associate professor, and I have been in teaching field since 15 years. And with respect to publications, recently, 3 publications have been added into my profile, 2 Scopus and 1 is SCI. So the today's topic is cryptography. Why I took this topic as for today's session is that I have been doing research over this topic, and it made me go into with respect to IoT and different devices. So I'm going to start with modern cryptography. First of all, what is cryptography? Cryptography is nothing but the art of hidden writing. So secret writing. So crypto and graphy. So here we're going to convert the plain text into a unrecognizable format that is nothing but the cipher text, and we're going to send the data. So for example, here Bob and Elise are going to communicate with each other. This is the best general example we have been seeing, and this is the two characters we have been going through, Bob and Elise. So if Elise is sending the message to Bob, then she is going to use a key to encrypt the data that she is going to send to Bob. This is how the encryption is going to come into place. Now, we have different types of cryptographies over here. So first one is the symmetric cryptography. Then we have the public key or the asymmetric key cryptography. Then we have quantum key cryptography, ID-based cryptography, pairing-based cryptography, attribute-based cryptography, homomorphic cryptography. So these are different cryptography techniques with respect to modern cryptography techniques. Okay, so we have different types of ciphers over there: blockchain ciphers, substitution ciphers. Now these are the what we are going to discuss today is the modern cryptography. The first one is a symmetric key cryptography, wherein which symmetric key is nothing but we are going to share the same key between the sender and the receiver. So the plain text will be encrypted by using a key. So in here we're going to apply the encryption process, and so after applying the encryption process, we are going to have the cipher text over here. And we are going to send the data. If at all anyone want to see this data, then the data will be in unreadable format. Okay, they could not able to understand what type of data I'm going to send, because that doesn't contain any kind of a meaning into that. Then what the receiver is going to do, he is going to convert that ciphertext into the plain text. This is what we have been seeing. Okay, this is the basic thing which we all know. Now here this is the symmetric key cryptography, wherein which we're going to use the same key. We're going to use the same key. So we have different types of symmetric key cryptography. The best example we have is the DES, Blowfish algorithm. Okay, these are the different encryption techniques which we have with respect to symmetric key cryptography. Then we are going to go with the asymmetric key cryptography. In that asymmetric key cryptography, what we are going to do, we are going to have two keys. We are going to have two keys. So one is known as the public key and one is known as the private key. This public key is being known to everyone. So for example, Alice is sending the message. Alice will be having the public key as well as the private key. Alice will be decrypting the message. Alice will be decrypting the message, encrypting the message by using the public key of Alice. Okay, and and she will be sending the data. So whenever the Bob want to decrypt, he is going to use the public key of the Alice and he is going to use the private key of the Bob, and he is going to decrypt the data. So here none of the parties are able to say that I haven't sent the data and I haven't decrypted the data. If at all Alice is been involved with the fraud, like she is giving the data to someone else. Okay, then when she is going to use a symmetric key cryptography, then there will be an issue. So Bob cannot deny where is the mistake has gone wrong. So now here, that's why we are going to use two keys over here. even though the Bob is going to knowing the key of Alice, he need to use his own private key to decrypt the message. So here you can see the plain text. The encryption algorithm will be happening to whomever we want to send the data. Then we are going to use his public key and we are going to send the data. Okay, and this data transfer will be happening over the network. Okay, and here once the data is being received at the receiving end, once the data has been received at the receiving end. This guy, whoever is the receiver, he is going to decrypt the data. Okay, decrypt the data by using his private key. Okay, by using his private key. This is the symmetric key, asymmetric key cryptography. Okay, so here we are going to use only a single key. Here we are going to use a two keys. So here we have plain text, secret key, ciphertext, secret key, plain text. Here plain text, public key encryption. Then we are going to have the ciphertext, then private key encryption of the receiver. So we are going to use the private key of the receiver, and he is going to decrypt the messages, and he is going to get the plain text. This is what that is going to happen. So this is what that is going to happen. The next we have the quantum cryptography. We have the quantum cryptography. Here the date generally whenever we are going to send the data, we'll be sending the data in the form of bits, zeros and ones. Okay, we are going to send the data in the form of bits. Here in quantum cryptography, also known as quantum encryption, applies principles of quantum mechanics to encrypt messages in such a way that it is never read by any outside other than the intended receptionist. Here, what is the process that is going to follow? For example, Alice is going to send the message to Bob. Alice is going to send the message. Alice is going to send the message to Bob. Then here here the data will be sent in the form of 2 bits. It's not bit. The data will be sent in the form of 2 bit. Here we have BB84 protocol, the basic protocol which we are going to use in quantum cryptography. Okay, so we have these are the filters. Okay, the data will be sent okay in the form of qubits. So how the qubits are being generated? So whatever the data that is being there, the data will be traveling through diagonal and horizontal vertical polarized filters. Okay, so here we'll be having the filters. Now if at all I am sending the data, so the data will be converted into the light source. Okay, basically the data will be converted into the light source. So whatever the data which we are going to input, over here, the data will be zeros and ones only. But when the data goes into this polarization filters, okay, so here we have different types of polarization filters which we can see over here. One is the upward arrow, okay, one is the straight one is the down left side one. Then we have the different filters over here. Those are known as the diagonal polarization filters and the horizontal polarization filters. Now these filters are going to convert our bits into qubits. Okay, and so here you can see. So here we are going to apply these polarization filters. This indicates zero. This indicates one. Okay, this indicates zero. This indicates once again one. So likewise, the data will be the bits of the data will be going into the polarization filters in the form of light source, and it will be converted and it will be sent to it will be sent to the other side. Here the reverse engineering process is going to happen. Okay, so whatever the data this Mr. Bob is going to receive, he is going to receive the data in the form of qubits. Once again, he is going to convert that qubits into bits by using this once again the diagonal and horizontal polarization filters. So that is about quantum cryptography. Then we have the identity-based cryptography. So here in identity-based cryptography, basically we are going to use the public key. This is nothing but the asymmetric key encryption or the public key encryption, in which user's public key can be identified. Okay, can be identified to the corresponding private key which has been created. So here we are going to use a identifier. Okay, here we are going to identify. For example, I am sharing my public key. Okay, I am going to share my public key. So how my public key will be identified? How my public key will be identified? My public key will be identified with respect to an email address or the domain name or the physical IP address. So what I am going to add with my public key, what is the one more feature which I am going to add with respect to my public key is that I am going to add an identity to my public key. So for example, you can get everyone's public key, but how? So for example, I'm sharing my public key and someone is going to take my public key and he is going to use that, but he need to have the private key of the other. So how to not use that? What I'm going to add extra feature that to that is I'm going to have an identity to my public key by using an email address or the domain name or the physical address. This is how that will be happening with respect to identity-based cryptography. Now here you can see when Bob wants to send a message to Alice, he encrypts using public key of Alice. So for example, say that is KA. Now suppose someone own K, a malicious guy substitutes her own public key KM with Alice key. How does Bob come to know? So here the Bob will be coming to know that this is not the key of Alice by seeing the identity of the Alice. So this is how the identity based cryptography is going to happen. So we can see. So this is Alice is going to send the data. Okay. So and send the encrypted data, and Bob is going to take that data and he will decrypt. So how will Bob come to know that this is the public key of Alice? He is Alice. How? As Alice is going to add as a identity to her public key. Now, next one is pairing based cryptography. Now, the one more feature which I am going to add, okay, here with respect to the encryption, basically this is known as elliptic curve cryptography or here. Pairing based cryptography is based on pairing the functions that map pairs of points on elliptic curve. So here I am going to construct a identity. Okay. So here I am going to construct a identity based encryption which allows sender to encrypt message without needing to receiver's public key. So in general, what is going to happen whenever a sender and receiver are going to use the public key? For example, I am sending the data to Bob. Okay, I'm going to send the data to Bob. Then what I'm going to do in prayer, before only I'm going to share my public key. Before only I'm going to share my public key. So, and that public key will be certified by me. Okay, that public key will be certified by me. The public key will be certified by me. So this is how I'm going to certify that public key. I'm going to have a digital signature over the public key. Okay, so I'm going to pair my digital signature with respect to the my own public key, and I'm going to send. So whenever Bob is going to receive the data, then he's going to here we're going to have the pairing process will be applied over here. Depending upon that, he will be coming to know that this is the key of the sender guy. But as I'm going to send it advanced with a digital signature into that, so that is nothing but pairing based cryptography. Okay, so this is how it is going to happen over here. So in advance, the Bob is going to share, if at all Bob is want to communicate with so many different people, then he will be attaching his public key along with his digital signature, and he will be sending. So each and every public key of the user will be having his own digital signature, which will be paid. The next thing is which I'm going to discuss is attribute based cryptography. So in attribute based cryptography, here I'm going to add one attribute. Okay, So how I'm going to generate the attribute, I will be telling you. So the attribute which users can decrypt a ciphertext will be decided by the attributes and policies associated with the message and the user. So before I am going to send the message to anyone, here we are going to decide, okay, in a community, not to everyone. Okay, if at all we are going to share the data in a community, then we are going to decide what type of attributes and what type of policies we are going to, or what type of protocols we are going to follow whenever we are going to share a public key. So a central authority will create secret keys for users. Okay, so that is IBE. IBE based, identity based encryption we are going to apply over here. And whenever we are going to share this key, okay, ciphertext can be created by incorporating attributes and policies. Now here, whenever we are going to send the data, we are going to have the already designed protocols and the policies, and depending upon these protocols and policies, we are going to select an attribute. Okay, select an attribute, and we are going to send the data. So the attribute can be like which users can decrypt the ciphertext will be decided before, and the policies associated with that message and the user. So there will be a central authority with that. Okay, will create secret keys for users. Okay, the central authority will create a secret keys for the users, and they will be sending. So you can see here. So this is an example like how the attributes will be created. Okay, we are going to use functions like and or on functions to create a public key attached with an attribute. So here key policy will be there. This is the ciphertext, and whenever how this ciphertext will be created by using the public key attribute function. Then here we have the private key of the. Then whenever I want to decrypt this ciphertext, then already a protocol or the attributes have been communicated before they come in a community to how to take that public key, and by following these attributes and his private key, this encrypted message will be decrypted. So likewise, there are different types of encryption policies with respect to modern cryptography is there. So here today, the main agenda will be like we're going to see the security with respect to IoT. Okay, security with respect to IoT. So these are the different modern cryptography techniques. Next one we have the harmonic encryption. Okay, so what happens over here? So allowing the one to perform calculations on encrypted data. For example, simply I will tell you. For example, I want to send the data. Okay, I want to send the data like 1 and 3. Okay, I want to send the data like 1 and 3. Whenever I want to send the data, like I want, like Alice is sending, what is the answer for 1 plus 3? What is the answer for 1 plus 3? Then, so our harmonic encryption is in the form of encryption where you can perform operations on the encrypted data and get the encrypted result. For example, 1 plus 3 is 4, but she will replace 1 with some 33 or 2 with 54, and she will send the data. Depending upon the answer that is being generated by the receiving party, okay, she will come to know that the receiving end is okay. So this is the harmonic cryptography. Okay. Now we have seen the cryptography is going to play a vital role, or network security or the information security everywhere, whichever the field, the cryptography is going to play a vital role. So now we are going to see about how the cryptography is being involved with IoT. Okay. So I have a next slide with that. Yeah, I think everyone is able to view the next slide, IoT security. If not, please reply. Otherwise, I will continue. Thank you.
Sir, we are able to see the slide.
Okay, thank you.
Participants,
So,
are you able to see the slide?
yeah, they will reply when not an issue. I think they are
Okay.
receiving that. If not, I asked them to reply with a no. Yeah.
Okay,
So
thank you.
here IoT we have. What is an IoT? So this is the technology that has been came into existence recently. Like when I was doing my PhD, maybe 3 years back, when I started my work. So I have been doing with respect to network security in that. Then what I thought that at the time the IoT term was being trending term. So what I thought, why not to include security? Why not to discuss these security issues over IoT? So what is an IoT? IoT is nothing but Internet of Things. It's a collection of devices that are connected to the internet. So they are different devices that have been located at different places, and we're going to access those devices by staying at different places by using internet. So Internet of Things refers to all the devices, even those out of the ordinary, almost anything with on and off switch these days can potentially connect to internet, making it to be a part of IoT. So the best example of an IoT is a smart home. So whenever I want to go to my home, so it's a hot summer, so I want to switch on my AC. If at all my AC is being connected through IoT with and which I can access through my mobile phone, then what I'm going to do, I'm going to switch on AC before I go to my home, half an hour before I reach my home. So by the time I go to my home, the AC is switched on and I can feel the coolness over there. So instead of going there and switching on the AC, so I'm going to do that task by staying at different places. So IoT, so there are different applications of IoT which we have, like smart home. So you can have different devices like fridge we have. You can access your fridge by staying at home. You can lock or unlock the door of your house by staying at different places. Okay, and we have, that is an example of a smart home. Then we have smart wearables, like I have in my watch. Okay, this is a smart watch. So uh, this is a smartwatch. By this, this is the example of a wearable. Then we have smart city. So in smart city, we have the a smart building. We have the smart water system. Then we have smart energy system. Okay, so we have different street lights which have been enabled with a IoT. Then so depending upon the climatic change, I can switch on and switch off those lights. So for example, in summer, the light starts dimming by 6:30 and 7 o'clock. So I can have my lights, street lights switched on by after 7 o'clock. And otherwise, in winter, the light starts to dim like at 6 o'clock. So depending upon these conditions, I can use this IoT come into place. So this is just an example. There are lot many of examples with respect to IoT. So there are different applications have been there, like smart grid. So I can use IoT with respect to factories, power plant, hydraulic power generation. Then I have the industrial internet. So like I can access different devices of cloud by staying at my home. Then connected car. Okay, I can connect my car with respect to an IoT device and I can access that. Okay, connected health. So connected health, we have different variable devices. So with respect to that, I want to give an example. So there is a lot of examples with respect to that, and there are a lot of benefits that are going to happen with respect to different IoT devices. So we are new. Someone is exploring. Okay, we need to explore more with respect to IoT. Okay, and IoT devices. So I would like to give an example with respect to an IoT device. Mr. R. Rajans, okay, he's a 61-year-old guy. He was using a Apple Watch 5 series that have been gifted by his son. Okay, he is a heart patient. He was a heart patient, and so he stays alone with his son. Okay, so whenever son goes to the office, okay, so he feel insecure about his father's health. What he has done, he brought him a Apple 5 series watch, and he has given that watch, and he was wearing, and he was seeing, and his father was seeing under that Apple watch, and once again that Apple watch has been connected to the son's mobile phone, and he's also able to view that. So suddenly what happened one day, one day what happened when Rajan's son left to his office. Okay, just I will switch off my phone. Yeah, Rajan's son, when the son has left to his office, this guy, Mr. Rajans, has already having he has already had a heart stroke. Now, when he went to the office, he was feeling some abnormalities. Okay, these abnormalities he was able to view. Okay, he was able to view on the watch. Okay, he was able to view the view on like the watch is going to act as a smart ECG. So you can see over here, like I do have my watch where in which my ECG is being recorded over here. So you can see here, for that purpose I just switched on that watch. So that son, that father is Mr. Rajan is able to see a lot of abnormalities, and what has happened, see, he reported to his son, and see, he directly went to the hospital. So now when the doctors have checked his ECG, and it was totally abnormal, and suddenly they have performed a surgery, and the surgery was successful, and he was perfectly all right. Now what the doctor said, that if at all he has not come to the hospital before 1 hour, okay, then he might have got another heart stroke, and the doctors have already informed to the patient as well as to his son that if at all he is going to get one more heart stroke, then it will be very difficult. So it will be very difficult for him to recover. So luckily, with the respect to his IoT smartwatch, he was able to recover, and the son has wrote a message to the CEO of Apple, okay, Mr. Tim Cook, what the benefit that the watch has done to his father. So likewise, if at all we are going to use these kind of smart devices which are going to operate with respect to IoT, like with respect to internet by staying at different locations, then we can do a lot of good things that will be happening. This is just an example of that. Now, what are the different common applications? I said, okay. So like different applications I already said. So now, next thing, we're going to get into the topic. What is IoT security? I said, okay, we're going to with these IoT devices, these are the smart devices are going to work smartly. Okay, sometimes they are making us dumb also. So they are going to work smartly. So the different examples I gave, like smart home, smart city, smart health connected to smart health issues like devices, like variables like watch, okay, telehealth care, clinical trials and visualization. They are different things. So now everything comes with an advantage and as well as a disadvantage. Okay. Today in my session, I'm not going to show you any practical like hands-on session with respect to any kind of a tool. Okay. So today I'm going to discuss with the IoT security, and if at all next session may be given, then I may think with respect to a how the smart IoT security is going to work. So today we're going to discuss about what is an IoT security. Now, whatever I discussed, what is an IoT? Okay, what is an IoT and what is the different advantages of IoT I discussed, and simultaneously we do have a lot of disadvantages. Now, so basically, what is IoT security? A robust IoT security portfolio allows developers to protect their devices from all different types of vulnerabilities while deploying with respect to security level. So let me explain what is IoT security. Now I am using my watch. Okay. Now I'm using my watch and I am going to monitor this watch. What if this watch, okay, this is being connected to my phone, or this is being connected to my friend's phone or my relative's phone or my sibling's phone. Okay. Now if a phone has been hacked and okay, if a phone has been hacked and then if the watch which I'm going to wear has been taken into control, okay, and taken into control, then whatever the abnormalities that has been found with respect to the other example which I gave, that that abnormalities may not be known to the patient or his son, if at all that the watch or the device that has been hacked. So now the disadvantage is that he will be in illusion that okay, I'm wearing a smart device, okay, I'm safe. What if this smart device is being hacked? If it is not going to send the signals even at a like emergency condition. Okay, this is an example with respect to a smart wearable device. Now what if my smart home is being hacked? Example, there is a smart door. Okay, the smart door which has been activated. Okay, which has been activated by my security. Okay, like by seeing my biometrics or by seeing my. I'm going to use my mobile phone. Okay, to unlock the smart lock. Okay, so I too can use my mobile phone. So what if this smart lock has been hacked? Okay, so these are the different security challenges which we have. Okay, so now what are the different disadvantages which we are going to have with respect to IoT devices? Okay, different security challenges which we are going to have with respect to IoT devices. So IoT devices are very small. Okay, so they are not like a computer, or they are not like a laptop, or they are not at all like a mobile phone. Okay, they are very small. The simple example of an IoT device is a Raspberry Pi. Okay, or which we can include and program on that. Okay, but they are so whenever you are going to use these IoT devices, okay, these have been hacked. So for example, let me take an example of a precision agriculture. If I am going to use an IoT device, so IoT device is nothing but I'm going to use a RFID radio frequency identification device. Okay, I'm going to have a RFID device which is being tagged to a plant. Okay, which is being tagged to a plant. This RFID device is a very small chip which is going to tag to a plant. Okay, so now this RFID device, the major problem is that they don't have their own power. Okay, so they cannot have their own power supply. So I need to see a medium, okay, or whatever the battery which I'm going to insert that, or whatever the power that which I have initially, it will be to a particular time. So it doesn't have a power of its own. Now this RFID chip has been tagged to a plant in a tagged to a plant. Okay, if I'm doing a farming, okay, tagged to a plant. Now, what this tag will do, it will send me the temperature the plant is environment in which the plant is been living, the moisture that the soil is going to have. Okay, depending upon that, I can use on another IoT device to switch on the motor. Okay, to have some water into that. So now, what if this device has been hacked? So I will be sitting somewhere and I will be in illusion that my farming is going on well, okay, but it is being hacked and it is sending me a signals that it is good. Okay, it is being good. It has been hacked. Now I am in a illusion that it is not in a it is in a good condition. Now, so after some time when I come to visit, I could able to see it is not in a good position. So at that time I want to do something, but already the damage has been done. So this is then one of the disadvantage with respect to precision agriculture. Okay. So what are the challenges over here? So weak default passwords, because I cannot have a device which is being kept into that chip, okay, which can process the encryption and the decryption techniques over there. So there will be a default passwords which can lead to security issues. Even if the passwords are changed, they are often not strong enough to prevent infiltration, because I cannot have a very strong password over there, because it has some certain limitations with respect to that RFID tag or IoT device. Just a minute. The second challenge which we have is lack of encryption. That's what I have been telling. Although encryption is a great way to prevent hackers from accessing data, it also one of the leading IoT security challenges. So the devices lack storage and processing capabilities that would be found on a traditional computer. What is it? So like the traditional computer, which have like a minimum of 4 GB to 10 GB RAM, and it has a lot of storage, and I can apply different types of encryption and decryption algorithms over there. But that IoT device doesn't have. So the result is an increase in attacks where hackers can easily manipulate the algorithms that are designed for the protection. So I have already embedded into the chip with a small algorithm. Okay. So but that so small algorithm may not be in a position to protect this data from the hackers. So unless an enterprise resolves this issue, encryption won't be a security asset to the IoT device. So the next one is the outdated legacy security. So we have seen different types of vulnerabilities of IoT devices. In addition to that, the other concern is that with interconnected legacy systems, which we have been using from the long, so an enterprise with a growing number of IoT devices, legacy technologies might seem out of place. Okay, these technologies might be seem out of place. So whatever the older systems or older types of encryptions, legacy software which we are going to use may be outdated one with respect to new. As technology comes with new things, it has both pros and cons of that. So we need to update with this outdated legacy security. So then other thing is the phishing attacks. So you know about phishing attacks with respect to cryptography. Okay. So a hacker, for example, a hacker will try to send a email, okay, stating that you have you need to reset the password. It has been become old. Then whenever you are going to click that URL, it will lead to the hacker's site. There you are going to reset the password, and this password will be known to the hacker, and he is going to take care of your thing, and he is going to do damage to your networks and the things. So similarly, here phishing is a already security concern across all enterprises, technologies, and in IoT also. IoT devices represent the latest attack vector with respect to this phishing. Hackers could send a signal to an IoT device that triggers numerous complications. Although this is one of the most common forms of security attacks, it can be stopped. Many organizations fail to properly train their workers. So, phishing. So, with respect to phishing attack, what happens? A hacker is going to try to access an IoT device. Okay. So now, even though he's not going to access that, he's going to send different types of complications to that IoT device. Okay, by knowing where the RFID tag. Okay, so whatever the RFID tag or whatever the device that is going to have the security, that may not be sufficient enough to overcome this kind of attacks. So there will be a lot of malfunctioning with respect to that IoT device. So these are the different types of phishing attacks that will be happening over here. Okay. Hello, madam.
Yes, sir.
Actually, I have been connected with. I haven't connected my laptop to the connected to that, and once I have connected, the power has gone. So almost like 20 to 30% of battery is there, which will continue for some like 20 minutes. Most probably, the power supply will be coming. If anything issue happens, then what I'm going to do, I'm going to continue with my mobile phone. Okay, will that be okay?
Yeah, okay, sir.
Okay. Is there any break in between, like, or shall I continue with 2 hours of session?
Yeah, 2 hour session, sir. There's no
Okay,
break.
not an issue. Okay,
Yeah.
thank you. Madam.
Okay, thank you, sir.
Okay. Just 1 minute, madam. I will be once again joining.
Sure, sir.
Yeah. Sorry, guys. Once again, I make sure that the power is there. Okay, just inform, and I got the power. Not an issue now. Yeah, phishing attack. So These are the different IoT challenges which we are going to have. Okay, these are the different IoT challenges which we are going to have. So likewise, we have different threats. Okay, an attack of disable. So now with respect to a car, okay, now I have a car which has been connected to an IoT device. Okay, and I'm going to see that I'm assuring that this car is functioning well. Okay, this car is functioning well, uh, functioning well by as each and every main part of the car has been connected to an IoT device. Now, an attack on disabling the brakes of a connected car. Okay, for example, or a connected health device such as an insulin pump hacked to a administrated too much medication to a patient. So like just an example which I'm giving, like with respect to a car, okay, which is being which for which the brakes have been connected and these brakes have been disabled by a hacker. Okay, or to a patient who has been connected to a insulin pump, okay, and which has been monitored, okay, which has been hacked. Okay, so likewise there are different attacks that can happen to a refrigeration system. For example, in my home, this IoT device has been connected to a refrigerator. Okay, so this refrigerator has been hacked. Okay, and whatever the things that have been kept in the refrigerator or whatever the what I said about car brake failure system or insulin pump which is being regularly given to a patient which has been hacked and is not been given, okay, then the adverse effects of IoT is going to start over here. Okay, adverse effects of IoT is going to start with respect to here. So what we're going to do? So I have proposed a solution for that. So here a attack against a smart door locks could potentially allow a thief to enter into a smart home. Okay, in such scenarios, such as 2013 target, so that has happened in US, wherein which the burglar has access to the smart lock of the house, and he entered into the house, and he has created a havoc over there. Okay, now these are the different threats and the different issues, okay, or the disadvantages which I have discussed with respect to IoT and security. Okay, so what are the common IoT security measures which we can take? Okay, so I can take a public key infrastructure PKI and why not 9 digital certificate. Okay, so what is uh, PK is nothing but public key infrastructure. Okay, it is a standard for the digital certificate. Okay, and 509 is a standard for defining the format of public key certificate. Okay, so now I'm going to define the standards with respect to PK and digital certificates. Then I'm going to provide a API security, application performance indicator. So this is a security essential to protect the data. Okay, to protect the data of being sent from IoT devices to back end systems and ensure only the authorized devices and developers and apps communicate with the APIs. So are able to get this point. So here I am going to have a application performance indicator. So what it is going to do, so it is going to protect the integrity of data that is being sent over the IoT devices and back to end systems and ensure that only the authorized devices. So whichever the device, okay, whichever the device which is going to use, whichever the device which is going to use this particular authorized IoT protocol and which is being set up at home or different locations, that device I'm going to use that. So what these authorized devices are going to do, they ensure, okay, security with respect to authorized devices, developers, apps communicate with the APIs. So these all devices will be communicated with the API, and I will, if at all any kind of security breaches are going to happen, then it will be known. So incorporating the security at the design phase. Now here, whenever I'm going to prepare, whenever I'm going to make an IoT device, okay, an IoT device, for example, now I'm designing a proposal for with respect to drone, like, with respect to DDP project. So with respect to drone, I'm going to design a drone, okay, which can visualize which have a better vision with respect to seeing the things and taking care of those. Now, when I'm going to design any kind of a device, IoT device, then at the design phase itself, okay, whenever whatever the chip I'm going to insert into the device or whatever the technology which I'm going to insert with respect to security, I'm going to see that a better security mechanism is being provided, okay, at the designing phase of the device itself, okay. And the last one is network security, okay. Network, so protecting an IoT networks. So at the end of the day, whatever is the communication path, whether it is a wireless or wired, okay, or how the data is being sent, it will be sent through internet, okay, with respect to IoT device or wirelessly. Now, protecting the IoT network, okay, protecting the IoT network includes ensuring the port security. So whatever the ports which I'm going to have, so disabling the port forwarding and never opening the ports when not needed. Okay, using anti-malware, firewalls, intrusion detection systems. Okay, prevention detection as well as the prevention systems, blocking unauthorized IP addresses and ensuring systems are patched and are up to date. So these 2 points with respect to the security measures have been taken, then definitely we are going to stop IoT devices malfunctioning or hacking by others. So the first, this one is over in the design phase itself, I'm going to incorporate a better level of security. Maybe I'm going to provide a better space or storage to the device. I'm going to allocate that device with respect to designing an algorithm with respect to a security. And here, network security, I'm going to provide a better network security. So ultimately, the data will be traveling to a network. Okay, so I'm going to see that this data, okay, this data is being securely sent through a network. So protecting an IoT network, okay, includes, I said about just now, port security, okay. So whenever I receive the messages, I'm forwarding that, I'm not going to disable that. So these types of security measures we're going to have, okay, we're going to have to a IoT device so that a better IoT functioning will be happening. So IoT solutions allow companies to easily take advantage of the benefits of IoT to a robust, secure, and powerful grid of connected devices, buildings, and infrastructure. With accessible and transparent data from the network's edge, companies can gain insights into operational efficiencies and new revenue sources. So this is the solution with respect to the IoT. Now, in the next PPT, I'm going to provide you a solution which I personally work with respect to my research in IoT smart home, okay, smart home. So what is that? I will tell you now. So now we are moving into, we have discussed about cryptography, we have discussed about IoT. Now we are going to combine cryptography and IoT and its security issues. So now I already said about the introduction part. So this is one of my solutions, one of my algorithms with respect to IoT smart home. So I'm going to do introduction. I already discussed with respect to the previous PPT. Now, smart home is one of the important IoT use cases. So here I'm going to take a use case of a smart home. So there are different use cases which I can take: smart healthcare sector, smart grid computing, or IoT, okay, or precision agriculture. Now I am taking a use case of a smart home. Here, smart devices are used in houses, and there will be a digital and physical objects connected seemingly with the RFID and sensors and other devices. Now, here, let me take a now. So why I'm just scrolling down this PPTs is that whatever I discussed previously, the content is same. Okay, so it will take a lot of time to discuss all this kind of stuff. So here on abstract view, what I'm going to tell you is that here I'm going to take a use case. Okay, use case of a smart home. Okay, so they developed a web interface to view connected devices of smart home, and they can control the environment from remote place as well. Every device in the home is associated with RFID tag, and yeah. So now here in this use case of smart home, whatever the device which I am going to operate, okay, each and every device is going to have a RFID tag. Okay. For example, in my house I have a fridge. Okay. In that fridge, for example, I kept a tray. Okay, a tray of eggs. So there is a tray where I'm going to insert some eggs. So this tray is going to contain about a RFID read tag. What this RFID tag is going to do, it is going to tell you about how many eggs that tray is going to have. Now, someone has used, my family members have used eggs in the tray, and the tray is about to get empty. If it is about to get empty, then this tray, which is in a IoT device with respect to a RFID tag, it will be sending a message that the eggs in the tray are about to get over, and what I will do when I'm coming to home, I will bring that. So this is just an example, okay, how the devices in a smart home have been connected, and they have been like used for the advantage of smart home. So here it then involves the authentication with respect to IoT applications. Now in context of IoT connected devices, okay, it is essential to have authentication mechanism. So ultimately, when someone wants to enter into my home, okay, in my home, and that home is a smart home, okay, I'm taking a smart home use case, so I need to provide authentication. So now here I'm going to propose, okay, I'm going to propose a mechanism wherein which it is known as cloud assisted authentication scheme. This is known as cloud assisted authentication scheme. So this scheme is going to have a tag. This is the item for that item that have a tag, and this item is being connected to the to my device, okay, by using a network. This is the internet, and there is a tag reader, okay, and this reader is going to perform different actions depending upon this tag and item, okay. So this item is going to have a tag. Now what I am going to do, what I have done to this problem is that whenever any person gets inside into my home, okay, then that identity of the person will be checked. How the identity of the person will be checked? Maybe by using a thumb, or maybe by using a biometrics, okay, maybe by using a facial recognition technique. Now what this RFID tag will do, okay, it is going to be inserted to a particular item, and the RFID reader will read the data of the person. For example, I'm going to already insert the data, okay, I'm going to insert the data into that device, and that device knows me, okay. If someone unknown people comes, okay, then it is going to raise an alarm if he is going to stay for some time period, okay, and he's trying to do something he's trying to access without proper access. Now it is going to raise an alarm, and that alarm will be I will be getting a signal, maybe in my house nearby the alarm will be raised and everyone will be coming to know that. So now, so a methodology where communication takes place among RFID tag, RFID tag reader, backend server, and this backend server is known as authenticated cloud server. Now, whatever the data which I am going to keep, okay, for example, I said previously that there is a lot of data that should be required to insert into a device, but we cannot insert it because it is not at all accessible. So now whatever the data that is being related to a particular company, for example, a company is going to have thousands of employees, okay, and all this data I cannot feed into a single chip. So what I am going to do, this RFID, I am going to insert a tag and a reader. RFID reader will be there, so tag reader will be there. Whenever a person is going to come, then that person is going to read, okay, by using the person's, what is the device is going to do, it is going to read the person's tag, and it is going to send a message to the server, okay. This server will be located at the cloud, like I'm keeping all the data over there, and it is going to map with that. If everything goes well, then opening of the door and allocation different things will be done. Each entity in this process of secure cloud assisted authentication has its own role to play. So each and everyone will be having his own authentication policy, like I have my own RFID tag, and I have my own RFID tag reader. So when I go to someone place and I want to access that, if they want to allow me, then I need to before that I need to submit them to my credentials, and my credentials will be activated over there, and whenever I go, then automatically the door opens, and I will be getting into the house or any place. So this is how the things will be happening. Because of storage space is very less, what we are going to do, we are going to store all this data over a cloud, okay. We are going to store all this data over a cloud, okay. So the proposed architecture for the RFID networks is integrated with the cloud. So whatever the proposed methodology or whatever I have proposed, I have done is that I have integrated RFID networks with the cloud. So this is the system model which we have. We have ACS, authenticated cloud server. Below that we have cloud. We have the backend servers. Okay, and this is cluster 1, cluster 2, cluster 3 is nothing but these are different set of devices. Like this is maybe this is a device that has been there at my home or at a particular place. Okay, this is RFID reader. This is one cluster. So this all these clusters will be communicating with a backend server, and this backend server will be communicating with a cloud. And here authenticated cloud scheme will be there. Okay, so authentication. So here we have ACS, authenticated cloud server will be there. Whatever the data that a particular person is going to come in, okay, whatever the data that a person is going to come in, and whenever he's going to insert his chip, okay, when he's going to come in and he's going to insert his chip, okay, this RFID reader will read that chip. Okay, I have inserted, and it's going to read the chip, and a message will be sent to the backend server, and the data will be there in the cloud. Okay, my data, and it is going to authenticate the data.
Hello. Hello, sir. Hello, sir.
Something went wrong. We are trying to get back to. Hello, madam.
Yes, sir. You went off for some time. I was trying to call you, but your mobile is switched off.
No, madam. My network has been connected, but I could able to see a message that is popping up over here that something went wrong with respect to the other end. Anyways, okay, madam. Now it's okay as of now.
Okay.
Okay. Once again, I switched on my mobile. You can contact me. Okay, not an issue. Okay. Okay. So now, so in this system, okay, in this system, just a minute. Okay, please continue, sir. Okay. Now, here in the system, there is a RFID reader. It will be communicating with a backend server, and my credentials are being verified over there, and I will be allowed into inside. Similarly, the same system can be implemented with the different devices. Someone wants to I'm going to give access of my device, my wearable device, to my relative or to my friend. Then this access will be authenticated. Okay, authenticated to the data that have been stored in the cloud. So how it is being authenticated? The authentication the authentication takes place, like there will be RFID device, the RFID reader will be there. Okay, this reader will read the tag, then the data will be sent to the backend server, then it will be matched with the data that has been there in the cloud, and there we are going to provide a authentication scheme. Okay, so the data which is being stored over the cloud, to access this IoT device, will be there. I'm going to include a authentication scheme. Okay, the authentication scheme may be I am going to secure my data on the cloud by using different algorithms. Now, directly I cannot insert a authentication algorithm to a device, to a RFID reader. Okay, to a RFID reader, I cannot have many things in that. For example, I have a RFID reader. Okay, that reader will just read the data. That's all. So it cannot perform the different types of authentication schemes. It cannot have different types of authentication algorithms or any kind of public key algorithms or private key algorithms in that, so that I can secure my data. So what I am doing, I am not storing the data. I'm not storing the data in the RFID device. I'm storing the data over the cloud. So simply my credentials will be sent over there, and depending upon that, I'm going to access that data. Okay, from the cloud. Okay, that data from the cloud. This is how this system is going to work over here. So with respect to the use case of a smart home, okay, how this system is going to work. Okay, I'm going to my home. Okay, after going to my home, I will be having a RFID tag with me. Okay, and at my home, at my door, there will be RFID reader. Okay, so when I'm going to insert the tag, the RFID reader will read the data. Okay, and it will just send the data to the backend. Okay, so just simply like my name and other things, and it is going to verify. Okay, verify the data in the cloud, and if it is okay, then I will be given the permission to enter into my house. Similarly, I can take a use case of a car which is being automated, use case of a wearable device which has been automated. Now there is an issue over here. Okay, the issue is I'm carrying the tag. Okay, I'm carrying the tag. For example, this is the RFID tag. Whatever the tag which I'm carrying, okay, I have lost the tag. Someone has stolen the tag. Okay, I took this card to my office. Okay, there at the office, I lost my card. What I thought is, anyways, I lost my card. I will create a new card with respect to RFID reader and everything. I thought, and I just simply kept quiet. This tag went to a thief or to a hacker or to a intruder. Okay, suppose this tag has been founded by the intruder. Okay, now otherwise we can also assume that this RFID tag has been made tag, the user has made a duplicate copy of that. Once again, this authentication process will be happening at the cloud server side. Okay, so he lost or he made a duplicate copy, he came to me. Okay, he is able to, if I lost the card, and he is able to access, and he can get inside and he can access my home. Okay, so next level of security which I can provide with respect to this system is I can include a biometrics. Okay, I can include a biometrics into that, or I can include a facial recognition system wherein which double two-way, okay, that is more stronger security will be provided to the home. Okay, two-way security will be provided to the home. So in this system, we are only seeing about cloud assisted authentication scheme. Then I can have a cloud assisted authentication scheme including biometrics or the facial recognition system. Even though if I'm going to lose the tag, then he cannot be able to enter into my house. So that is the next level of security. So here comes the multimodal cloud assisted authentication scheme. Multimodal cloud authentication scheme. So here RFID critical IoT application mechanism applications need mechanisms to have secure communications. Towards this end, the RFID based cloud authentication scheme is proposed. So which is just now I discussed. However, the authentication provided can be expanded with the multimodal scheme. Okay. So in the multimodal scheme, what I'm going to do, just go through this diagram. I'm thinking about that. So here we have different authentication scenarios and security issues. So this is authorized person with a authorized tag. I am authorized person, I am authorized tag with the authorized tag in my hands. Here I have RFID reader, I have camera, and this is cloud server. So this is cloud, a multimodal, it's not a model, it's a model, multimodal cloud assisted authentication. So what is that? What does that mean? So here we have another scenario, unauthorized person with a authorized tag. Just now I said that situation. What if like I'm going to lose, I lost my tag, and what I need to do? The third scenario is unauthorized person with an unauthorized RFID tag. So he tried to make a duplicate copy of that somehow. Okay, and he's going to enter. So here we have different scenarios. Okay, we have different scenarios over here. So at this junction, we have RFID reader and a camera will be there. So if I am a authorized person with an authorized tag, so what the first level of security will be, the RFID reader will read my tag and it is going to match my credentials. Okay, that on the data that is being stored on the data once again is being encrypted and that is being stored over the cloud. Okay, the data has been stored over the cloud. It is going to match with that data, and if I'm an authorized person, then it is going to let me inside. Okay. The second level of security is that it is also going to verify. Excuse me. It is going to also verify my face or retina or my thumb. So I have one, but second level of security or third level of security. So everything is matched. Then this scenario one, I am going to get inside. So what is second scenario? Just now I said to you people that I have lost my card, and that card has been got into the hands of some unauthorized person. What he will do? He will take this card and he will come and he will keep. After keeping, I think the PPT is able to move. I got a message that PPT is frozen. Is that now? Is it okay?
Yes, sir, it's fine.
Okay. So the second scenario which we have here is a person who got my tag and is trying to enter into my house. So RFID reader will read the tag and it is going to map with the data that is there on the cloud, and it is going to let me go inside. But once again, I have a camera that is being inserted or functioning along with the IoT device. This camera will take the facial recognition technique, okay, and it is going to map with the data. It is going to map with the data that is being stored on the cloud. So in second scenario, the first level of security will be okay. He's going to breach the first level of security, but at second level of security, there it is not going to give the access. So here he will be stopped. The third scenario which we have is unauthorized person with unauthorized RFID tag. So now I tried to make, or someone was trying to make a duplicate copy of my tag, and he was trying to get inside. Okay, he was trying to get inside. The first, so maybe the tag is going to contain maybe the tag is going to contain the my credentials. Okay, so like my username, the identity, etc., etc. But whatever the data, okay, whatever the data that tag is go duplicate tag is having, the data may not be matched with the data that is being encrypted and stored over the cloud. Okay, that may not be matched with the data that is being encrypted and stored at the cloud. So here the first level of security and the second level of security is going to stop the unauthorized person to get into the house. So the proposed model, how it is going to work. So this is the cloud server. Here we have the RFID tag. Then we have the image references. So these image references will be generated when I'm going to enter into my house. They are going to capture my image. It is going to map. Okay. So we'll see that how the things are going to work over here. So here we have the RFID tag. Okay. Tag is been detected. Okay. If it is detected, then okay, then I'm going to, then the RFID the device is going to capture my image, and it is going to compare that image with the reference image which is being stored over the cloud. If both are okay, then the unlock the door will be happening. At the first level, if the tag that is been detected is not the tag, then a alarm will be raised. Okay, the tag is okay. Okay, he got a duplicate tag and everything has been perfectly done, but when he is entering into the house, then image will be captured. If image is okay, then unlock the door. Otherwise, once again, the raise of the alarm will be happening over here. Okay. So this is a proposed multi-model. So here we have two level of security, or we can go with some more, like this is the proposed methodology, and I could able to generate a very good results, and still I'm working upon that. Okay, many things. So again, I'm planning to improve like one more different models of security mechanisms over here. So the more the security levels, okay, the more the security identification levels, the more security will be provided to the different IoT devices. So like whenever I'm going to analyze the data sets with respect to the facial imaging, here image processing is also going to come into existence. So whatever the images whatever the captured image will be there. Okay, whatever the captured image will be there. Okay, so that image will be once again verifying with the image in the that has been stored in the cloud server. So once again, these images will be encrypted and decrypted. So otherwise, if someone can take my image and he can feed directly to the captured image, and he can access, or he can store that image over my cloud server by hacking that Okay, he can that for that better purpose. What I have done is that I have applied different image processing techniques to see that the second level of securing the data with respect to my facial. Here I'm going to apply the image processing techniques to secure the data. Now, the next thing is secure and privacy preserving access control. So one more, this is the latest proposed one. How to enhance the security that has been discussed. Here, a cloud assisted RFID authentication for smart home access is being proposed, which I thought that this may be a solution to the different IoT devices. Okay, so like I have been saying that now, well, I think you have come to a small definition of a IoT. What IoT is actually. Okay, so any device, maybe a RFID radio frequency identification device, that is also a IoT device. When it will act as an IoT device, unless and until it has been connected to a network. So a RFID device is connected to a smaller network. Okay. Here in IoT, it has been connected to a larger network. Here in IoT, it is been connected to a larger network. So larger network in the sense, if you go to this diagram, okay. So here we can see it is a one cluster. Okay, this is another cluster. This is the another cluster which we have. Okay. Now, these two clusters can form a RFID network. This is another network. Likewise, different clusters can form a RFID network. Now, a cloud-assisted authentication scheme is proposed without the need of overhead of certificate authority, CA, or the trusted third party. Now here, whatever I said, that I'm going to save the data. I'm going to save the data over the cloud. Okay, my data, and there I'm going to apply. There I'm going to apply the encryption, decryption process, or the authentication process has been applied over there. Here, there is no need of third party, okay, involvement. So directly I can take my data, okay, I can keep it over there. I can apply my own algorithms, okay, my own algorithms for defining, for recognizing the tag and the face, okay. The authentication framework represents secure communication between RFID reader and cloud server. So whatever the authentication framework that have been presented over here previously and which has been proposed, which just what I started is initially is that I started with the security cryptography as a topic has been given like cryptography. Then I went into I took cryptography into IoT security. Okay. Then I came and proposed a methods with respect to solutions with respect to IoT security. So slowly it led to this diagram proposed method. So the authentication framework represents a secure communication RFID tag reader and server. The framework also defeats insider attacks. Okay, so I said when the security breaches with respect to IoT devices have been discussed. So they are different types of attacks. So inside attacks can also be identified and they can be come to know. So it employs threshold cryptography for achieving this. Okay. So here we are going to see a threshold cryptography for achieving this proposed method. Just a minute. So here I proposed a RCAC framework. This is a algorithm. Okay. Radio cloud assisted computing algorithm. Okay. Now, this is the next level of security which is being provided over here. So here there is a issuer, there is a secure channel. Okay. So now in this framework, in this framework, if at all I wanted to register with a secure mechanism of sending the data. Okay, secure mechanism of sending the data. Okay. In the framework, issuer will have a secure channel. Okay. Through that secure channel, a tag reader will be generated. Okay, a tag reader will be generated, and the tag reader will be generated, and whatever the tag reader that is going to generate, it will be going to the cloud server. So all the data will be stored, at a cloud server. Here I have used Amazon EC2, Elastic Compute Cloud. So whatever algorithm which I have designed, I said that I am going to store the data. Okay, I am going to store the data over the cloud. So what type of cloud services I have used to store the data? Okay, with my experimental setup. Okay, so I have used over the AWS, Amazon Web Services, Amazon EC2, Amazon Elastic Compute Cloud. So here we have the issuer. So component encapsulation issuer. Here we have the server. Then we have relational database service RDS with respect to the RFID tag reader. So this is component encapsulating tag reader with respect to the my tag. Okay, this is Amazon simple storage service. So for that purpose, we have done a course with respect to AWS. There, when I paid for that course, they have been given us 1 year of AWS service for free of cost. So I use that, and So this is a setup of the cloud environment wherein which all the data has been stored, and the data will be computed with RFID tag reader and other things. Thank you. Anything to ask for, you can ask.
Any questions, participants? You can chat in the chat box, or you can speak to sir directly. Any questions?
Actually, I need to leave at 12:30 as I'm the external examiner for computer networks lab. Okay, so
Okay, sir.
yeah, that's why. Yeah. Okay.
Okay, I think no questions, sir. Thank you for such a wonderful session, sir, and thank you for all the new techniques which you have implemented. Thank you so much for this wonderful session.
I would like to thank once again the Gopalan College of Engineering for giving me a chance for this great session, and especially special thanks to Somashekar sir. Thank you
Sure,
all.
sir. I will convey. I will convey, sir. Participants, the next session will start at 2 o'clock. It is it's by Mr. Sanjay Kumar. The topic is forensic usage in IT companies and self-investigation to collect ethic evidence. So please join in by 2 o'clock. Thank you.